All right, so looking at the next example, what we have is we have to find an exponential model. So we know that again to be f of t equals sum a e to the kt, and it's a model for depreciation. So that's another way of saying decay. We're going down. So that basically says I'm expecting my k to be negative. You don't worry about making it negative in the formula yet. It'll just come out in the wash. Watch what happens when I just do the math. But I'm expecting a negative value. What do we know? Well, we know that the car is depreciating, and it started with a value. So at time equals to 0, the car was $12,550. 5 years later, it was at $4,000. So there's my two ordered pairs that are going to help me find A and K. Well, there's your A, right? A, as we have seen, is always our initial value, right? How much did I start off with? So our model at this point in time is f of t equals 12,550 e to the kt. All right, it feels like my pen's kind of dying. Let me switch up pens here. I hope I grab one that works. All right, so now, right, we have this next data point. So when time is equal to 5, the output of my function is 4,000. So this would look like, right, f of 5 equals 12,550 e to the k times 5. But we know that the evaluation, when we evaluate that, comes out to 4,000. So we now have an equation that I can solve for k. So I'll begin by dividing both sides by that number. Right? The only thing I can clearly see is 0 goes out. And I'm not going to worry about the 5. That's a pretty big number. But we have e to the 5k equals that crazy looking fraction there. All right? And so to get to the k, I need to apply my natural log. Those cancel out, leaving us with 5k equals the natural log of that really big fraction. All right? Divide both sides by 5. And we get k equals the natural log of that really crazy fraction divided by 5. So let's go find our k. So we'll go to our calculator at this time, and we've got the natural log of 400 divided by 1255. And then we're going to take that number and divide it by 5. And what we get is k is negative 0.22, let's say 87. All right, so again, notice that we were expecting a negative k value, and I promised you if you just follow the math, that's what we end up with, the negative k value we're expecting. So our model then, right, is f of t equals 12,550 e to the negative 2287 times t. So there's our model. And if you want to, again, it looks like the rate of depreciation, right, it's going down about 22.87% each year, right? So it's losing value fast, all right? And so now we can use the model to do anything. In this case, we want to use your model to predict how long it'll take for the car to reach a value of $1,000. So it's not an input value, right? We're looking for f of t. When does that equal 1,000? So we'll just set our function equal to that and just follow the math. So I'll begin that journey by dividing both sides by that number. Again, just to help me out, I can clearly see zeros cancel out. So we have e to the negative 0.2287t equals 100 over 1255, right? I think it's not too bad to put 5 in there. I'll do that in a moment. So taking the natural log of both sides, that wipes clean. We have negative 0.2287t equals the natural log. I believe 5 goes into there 20 times, and 5 goes into here twice. 291, right? So twice, carry a 2. Oops. Let me just keep it, since I'm having trouble thinking that. Long semester. All right, and so t, if we do the division there, right, t is equal to the natural log of that nasty fraction divided by negative 0.2287. So again, we'll reach to our handy dandy calculator. and we'll get a nice estimate of that. So we've got the natural log of 100 divided by 1255, and then we're going to divide that by negative 0.2287. So it'll take 11 years, right? 11.0613. So roughly about 11 years for the car to reach $1,000, right? Again, according to this model, right? If it keeps depreciating almost 23% each year, right? So under this model, it'll have $1,000 of value after 11 years. So when I own the car for 11 years, at that time maybe it's just the scrap, right? The scrap metal, who knows? All right, so there's basically how you find a exponential model given data. Look for the data points. One data point should be an initial value, so that gives you A very easily. The next value allows you to solve for the K. That proportionality constant that we saw way back at the beginning of this. It usually, again, is a percent, all right, of decay, population growth, money growth, whatever the case might be, all right. And then, of course, once we have the model, like we did here, we can answer any questions. I can find a value by plugging something in. I can find when do I reach a certain output. We could have done that here or there. It doesn't really matter. We built the model. Okay, so hopefully that wraps that up. We're going to go take a look at another situation that involves exponential functions, but I'll do that in another video coming soon.